All right, so today we're going to be looking at some hockey data. We're going to be kind of going into this data, kind of discovering some new things, and we're just going to kind of go over and see if we can find some cool, interesting stuff about this data. So right here, the kind of the first thing I have set up for us real quick is going to be like the intro stuff. So I'm just kind of reading the data sets and reading in a bunch of these libraries that I just kind of want to have ready to go, just because I know I'm going to have to use a majority of these when I am going through my analysis of this data. So let's go ahead and look into these. Let's go ahead and run these up. So we can get a little picture. Actually, first let me sweep this out of the way. A fresh environment for us. Let's go ahead and run these. Let's see what we get. Cool. Okay. So now we have all these data tables here. And so let's just take a look and see what we got here. It looks like for the births, what this is, just based on the description from the original Tidy Tuesday website, this birth is going to be all the births in Canada in each month. So in 1991, in January, there was 32,213 births. Kind of a cool data set there. Here I have my players data set. This is going to give us all the players in the NHL ever in their birth year, which is pretty cool. Rosters is going to give us all of the rosters for each team, I believe, since 1917. Since 1917. So that's a huge thing. But the players can appear multiple times on the roster. So that's why we have 54,883 entries. And then teams is just going to give us a list of all the teams that have ever been in the NHL. Obviously, there's not 59 teams in the NHL, but some of these teams are no longer actually teams. So there's been some new teams added and stuff like that too. So that's kind of what we have to think about when we're going so far. As we're looking at this data set, we want to think about a couple things. A couple of the questions that I kind of want to really look at is going to be the count of birth cities for NHL cities born in Canada, or for NHL players born in Canada, how birth year relates to height and weight in Canada, how the team weight and height of teams per season. So basically, like trying to find the average height and weight per team per season. So like each season is going to have a average height and weight for each team. So try to find that, and then the percent of hockey players born in each month. So basically, that's going to be a little bit different one, kind of a cooler way to think about it. But like basically, if you were born in January in Canada, hopefully we'll be able to find a percent chance that you're a hockey player. So kind of looking at some different little elements here. So kind of how I have this set up is in each topic, I have already posted some of the code that I'll be working with. It's either going to be the graphing or it's going to be the actual data code. And then we'll do the other half of it. So I attempted this for a video for the first time and it was way too long. So I had to figure out a way to make it a little bit shorter. So I'm doing this so I don't have to type everything out, but I will still be typing half of the things or half of the analyses, and then we'll be going through the rest of it, obviously. All right, so topic number one, let's remind ourselves of what topic number one is the count of birth cities for NHL players born in Canada as a percent. So really, it's not the count, it's just kind of going to be the percent. So let's go ahead and kind of dive in here. How can we kind of look into this? Well, there's a couple different ways we can kind of start off. I'm going to start off by making this data set called players in Canada, right? And when we're talking about player's birthday, let's go ahead and look at this player's thing. And we see that we do have birth year right here. So, or actually, we're looking at birth city. So we actually, all the information we have in the birth, in the player's document or the data set is going to be everything we need for this. So we can look at birth country, we can look at province, and we can look at city. So pretty much this analysis isn't going to be crazy. Isn't going to be too crazy. It's really just going to kind of look into this players thing. But first off, we're going to kind of pipe into the players document here. And then what we're going to do is we're going to filter. I'm doing a lot of filtering today based on birth country. So why am I filtering off birth country? Well, I want to filter off birth country really just because I'm looking at a lot of this thing. I want to look at everything in terms of Canadian born players because one of my data tables, births, was really only for it was only for Canada. So I wanted to kind of focus on that in case I ever needed to kind of drag in that table. So that's kind of why I'm focusing on that a little bit over just in general. All right, so we're going to filter, and this is going to basically just filter out and make sure we only have Canadian born players. And so as we do this, I'm then going to get a count. Why am I going to get a count? Because we'll see in 1 second when I run this up. And we'll kind of see what this is actually going to do for us. So basically what this is doing is saying we only want players born in Canada, and then I want a count of all the birth cities. So let's run this up and let's see what we actually get. All right, let's see what we actually get here. Oh, okay, cool. So we get a little count function. This is going to be n. That's going to be the count of our cities. So this is, let's see what the most one is. Oh, well, that's the wrong way. Okay, so it looks like Toronto has the most Canadian-born players. So if you're born in Canada, there's a higher percent chance you're born in Toronto than any other city. Now, let's actually get this into a percentage. And how I can do that, I can use a mutate statement. So what I'm going to do is, actually, first I want to arrange this. So first I'm going to arrange that in descending form. Not necessary, but when we do the graph, when we talk about the graph later, we want to slice that for usually the top 10. I did the top 10 just because I don't care about all how many observations we have. 978. I don't care about all 978 cities. I just want to see the most likely cities. So that's why I was kind of thinking about arranging it descending wise. And then from here we can actually use this mutate statement. Excuse me, sorry. We can use this mutate statement, and I'm going to call this percent. And then how I'm going to mutate this is I'm actually going to do 100 times the n divided by sum of n. So basically, what am I doing here? I'm doing 100 times like the value for each city divided by the total, which is going to give us the percentage of the percent chance that if you're born in Canada and you're a hockey player, that you were born in this given city. So that's really what this is going to give us. So let's go ahead and look and see what this actually provides for us here. And then we'll be able to kind of see what we have here. Oh, look at this. Okay, cool. So it looks like in Toronto, we have 447 people that were born there, but then we have an 8.7% chance that if we're born in Toronto, yep, we have 8.7% chance, 8.17% chance that if we're a hockey player born in Canada, that we were born in Toronto. That's what this kind of data table is kind of telling us right here. That's the information that this one's getting at. All right, so let's go ahead and get to the graph. So the graph is going to be one of the things I already kind of worked through. So here's what we're going to look at. So right now we have this players graph, and we're going to use the same data set that we just made, players in Canada. That's kind of the data set we just worked with, and that's what we're going to use. Again, I have it arranging descending wise. That is actually probably an unnecessary part, so I'm actually going to just delete this off. And then why do I have this slice function from 1 to 10? Well, since R is indexed based on 1 and not 0 like Python is, we can go 1 to 10, and I'm going to get the first 10 things. So let's go ahead and do that and see what I get here with my players graph. And then we'll be able to see, so I do have 10 observations, my top 10 things. All right, that's pretty cool. So now I'm actually going to plot this, and I kind of have some nice titles and stuff here. So let's kind of walk through this. I have my ggplot. I'm graphing my birth city on my x-axis, and my y-axis is going to be my percent. I'm doing a column or a bar graph here, mainly because one of my variables can be categorical and not continuous. So we're going to do that. I have my title, percent of hockey players born in each Canadian city. And I always like to add a title on some axis titles because I think it just makes the graph easier to read. And I think it doesn't take too much time to add those in. So I love to add those in. And then let's go ahead and look and see what we're going to have here. So let's go ahead and run this up, and then we'll kind of talk through the graph a little bit here, and then we'll get to see what we actually get by these results. Okay, so let me put this full screen for us here. We can actually get a good view of it. Oh, and it's over the top of this. Oh my goodness. This is becoming an issue. There we go. Okay, so let's look and see what we have here. We have the percent of hockey players born in each Canadian city, as we kind of see with the title there. But what is this really telling us? Well, if we look at this bar graph, we can kind of look at, let's just look at Toronto for a second. So if we're looking at Toronto, we can see that Toronto looks like if you're a hockey player born in Canada, you have about an 8% chance of being born in Toronto. That's kind of what this is telling us. And it looks like Toronto is far and away the highest percent chance that if you're a hockey player in Canada, you'll be from Toronto, which makes sense because Toronto's a very big city and a very populous city in Canada. And then we also have other big cities such as Calgary, Edmonton, Montreal, Ottawa, and Winnipeg. So a lot of these cities also have hockey teams as well. So that also makes a lot of sense why there's a lot of hockey players from those cities, or a high percentage of hockey players born in Canada are from the cities that are a little bit bigger and also have a very strong hockey background. So that's what we're going to kind of look at first. And that's going to give us a pretty good idea of what our first topic was. So we were able to find the percentage of Canadian-born hockey players that are from each city, which is kind of cool. Next, we're going to look at how birth year relates to height and weight in Canada. So that's what we're actually doing next. And so right now, and like I kind of mentioned earlier, I have some of the code for each of these things already kind of printed out. So that kind of helps us go a little bit faster through this. So I don't have to end up making like an hour and 15-minute video, which isn't going to be good. So right here, we have topic number 2, data. So let's go ahead and look at this because this is just looks confusing to me right away. All right, so let's get in here. So what we're doing here, let's go ahead and look at this rosters document first. Let me clear these off if you're not going to use these. Let's get into this rosters document. All right. So it looks like we have a bunch of different stuff. And what I'm trying to get is birth year. Do I see a birth year in here? Well, I see a birth date. So since I see this birth date, I can actually split this up because this is going to be a string variable. And how I can tell is I can actually type type of, if I could type of, and then I'm going to go into rosters, and then I'm going to go down here, type of, let's go birth date, and then we'll just go 1. And then we'll be able to see that this is going to be a character right at the bottom of the screen right there. So since we know that this is a character, we can actually split this up using string split. So that is why I have this little thing here. What this is going to do, this string split fix is going to split this birth date up 3 times or into 3 separate little groups by this little dash. And so let's go ahead and run this and see what we get. All right, let's go ahead and get in here. Now, we didn't change the name of this. We just changed some of the columns. So we have our birthday column here, but then look at what we got here now. We got our year, right? We got our year, we get our month, and we get our day. So that's all we really need. So now we can kind of dive right into this analysis right now. So let's go ahead and do it. So rosters T2. So let's go ahead and dive in here and see what we get. Rosters T2 is going to be diving into rosters because that's what we're kind of looking at, right? Because we want to try to find the average height and weight by birth year. So we're going to group by the year. That's the column we just made, right? That's the column we just made. So that's our new column birth year. That is going to also be a character. It's not numeric, it's a character. So then what we're going to do is we're actually going to summarize. We're going to summarize. Now, when I was originally doing this, I had just done average height in inches and average weight in pounds. But I decided that when looking at this, I think it'd be kind of cool if we did more. So we're actually given in the rosters document, we are given height in inches, weight in pounds, height in centimeters, and weight in kilograms. So I decided to use all 4 of those. So what we're going to do here is let's go ahead and dive in and just kind of see what we're going to get when we kind of work through this here. Oh, also, I have this drop NA comment because there is rows in there that are that do have NAs in them, and that was affecting just the averages that I was getting. So I decided to just drop those out if they did not have a higher weight. So let's get into this rosters document, go into the year, and go all the way over here. And let's see what rosters T2 is going to tell us. We have 125 variables. Oh, look at this. We have our year. Now let's click this up and let's make sure we have, oh, why does it stop at 2005? Well, it stops at 2005 because this is a birth year. So the youngest players in the NHL right now were born in 2005, which is crazy because I was born in 2002. And I'm sitting here analyzing the data and they're playing professional hockey, which is crazy. But so that's going to be the youngest player. So that makes sense. It would not make sense if we saw like a 2015. There's no way somebody born in 2015 is playing in the NHL. So that's what we kind of have to watch out for here. But since we know that 2005 is the youngest player, we're okay. We're okay with what we see here. And what this is giving us, let's just look at this. This is giving us the average height in inches, the average weight in pounds, the average weight in kilograms, and the average height in centimeters. Now, we can also kind of look at these averages and see if they make a little bit of sense. Does a height of 71 inches make sense? Absolutely. Does a weight of 170 pounds make sense? Absolutely, it does. So a lot of these things, a lot of these numbers are making sense. So that's kind of what we wanted to look at too. So now that I'm thinking about it, there actually may be another way that we could have gone about this. We could have, since we have all the players, we could have actually done an inner join between the players and the rosters table. And then what we could have done, since we already have this birth year thing made, we wouldn't have had to string split it. So we could have done it that way, and then done stuff made a bigger table between those two using an inner join statement. So we could have done that, and that would have been perfectly fine as well. So that would have got us the same result here. And then what we're going to do is we're going to do a year count. Why am I going to do a year count? Because really just what this year count is going to get me, and let's run this just so I can kind of show as I'm talking. This year count is going to give me the amount of observations per year. So what do I mean by that? The amount of people that have each birth year. It's what's going to give me. So in each year, so in 1879, there's only one person that was born in 1879 that played hockey. That's what we know for a fact. But people that were born in 1940, there was 345. And if we go down, I believe in 1992, there was 1,062. And in 2005, there's only two. So we can see that a little bit different. And that's why in this birth year column, I'm going to make a data table called birth year, and I'm actually just going to combine this up. I'm going to combine these two tables because I want a little combined action here. I want to get that information from the rosters T2 and combine it with this year count data. So I have a little statement here. All right, so this is going to give us, yet again, the average height and weight, but now it's also going to give me the count of each, how many people were born in each year. So that's going to be kind of important as we kind of look at the graph, because when I graph this, I kind of want to include a little bit of both. Here. So now when we're getting into this graph, let's go ahead and do, we'll call it birth year graph. What we're going to be going into is we're going to be going into the birth year column here, or birth year data table here. And why am I going to use this filter statement that I'm about to use right now? I'm actually going to make this greater than 1994. So I want from 1995 to 2005. So why am I doing this? Well, if I go into my birth year data table, which is here, let me get some of these other ones off my thing here, clear up my space. I have 125 entries. I prefer not to graph 125 entries, and I prefer to take a look at maybe the last 10 years. So basically the people that were born in the last 10 years. So let's go ahead and do that. Oh, let's actually do 1995. That's going to be 11 years. Okay, so now I have this birth year document of the last 10 years. All right, it's going to be my birth year graph. And from here, I'm actually going to graph this, right? So I'm actually going to graph this. So let's go ahead and get in here and let's go ahead and graph this. Actually, the first thing I want to do is this. Now that I'm looking at this, because I'm remembering this is N. I prefer that not be N. So what I'm going to do is I'm going to get in here. And what I'm going to do is I'm actually going to get in here and change the column name of this because I really don't like the name N. I think it really, I think it just kind of isn't the best name considering what I'm trying to look at with that N. So I'm going to change that to just a variable called count or a column called count. So when I do this, it's just going to change the column name there to a variable or a thing called count. Let's check and see if it did it. And it did. So now we have a count instead of an N, which I kind of like better, even though the N is perfectly fine. But when I make it the table here, oh my goodness, if I could type really well. So we're going to get birth year graph. Then I'm going to get in here. And I'm going to do, when I graph this, I'm going to do year by. Now, how I'm going to graph this is I'm going to choose one of my variables and graph it by year. You can use whichever variable you want, but I thought this was a cool way to kind of look at it. Let's just choose average weight in pounds. So let's do average, how do I call this? Average weight in pounds. Okay. G weight P. So I'm gonna do average weight in pounds. And then what I'm gonna do is this. Size equals, oh, I have to capitalize this, count. So since size equals count, now I know that the size of whatever I do is gonna be that. So I'm actually gonna do another one called GM count. This is gonna give me a little interesting stuff here. So let's go ahead and get some titles on this thing as well, because titles are always a good thing. I'm gonna call this average weight per birth year in the NHL from 1995 to 2005. All right, average weight per birth year in the NHL, not GL, NHL from 1985 to 2005. Let's get some axes titles on here. What is this going to be? Our Y is going to be our average weight in pounds. And then what do we want our X lab to be, or our X label? We want our X label to be year. So now we have this like nice little thing set up here. And let's go ahead and see what this looks like when we graph it. Oh, nice. Okay. Let's put this on a full screen here. Oh, okay, cool. So when we look at this thing, what we kind of see here is we have our year on our x-axis, we have our average weight in pounds on our y-axis, right? And then when we look in, we can see that, yes, we're graphing the relationship between the year and this. So it is pretty consistent, it seems, up top until we get to about 2003. And the reason I wanted to throw in these counts is because you can see as the average kind of decreases, or the amount of players kind of decreases in each thing, the less consistent it seems. So it seems that once we get more players from 2003, 2004, and 2005 in the NHL, it'll become more consistent with what we've seen in the last from 1996 to about 2000. It'll seem to become a little bit more consistent there, even though we do have seem to see like a slight downward trend here, but we would probably expect that to kind of even out as there gets more players from each of those years into the league. So that's kind of what we would expect. So that really kind of shows us there. And that's why I wanted to include this count, because we're looking at 2005, there's 2 players there. So that's really going to skew that between those 2 players. Whereas in 1995, there's over 600. So that's kind of why we want to really focus on. All right, so as I was looking back at topic 2, I was kind of reviewing the video that I'd made. And I'm looking back at topic 2, and I wanted to make a couple of quick adjustments to topic 2, just because I feel like it's important to mention kind of where I thought I had messed up. So when I originally did topic 2, I did not factor in the duplicates in the rosters data set. I did not factor those in. So what I have done is I've gone back in and I pretty much left everything else the same except for these couple things I changed. And I'm going to go over the things I changed right now. So what I've changed is I've added this rosters new duplicate statement. So what this statement is going to do is going to eliminate the duplicates in my rosters data set. Since I'm doing by year, it's going to affect the weight by year if I have the same weight listed every single time per year. So what I need to do is get rid of all the duplicates in my data set. And then that's going to allow me to get a much cleaner data set here. Here, let's just go ahead and run this and see what we get. This is going to give us what rosters T2. So let's go to that and see. Yeah, so let me get this. And then let's go ahead and talk about what I did to the year count. What I've done to the year count is then look at rosters new, because then, yes, it has already eliminated those duplicate statements. I've also then filtered by birth country equals Canada. For some reason, I forgot to do that earlier. And when I was going back through, I just wanted to make sure that I made that clear that that was something that should have been done here for this year count to make it the exact same. So when we're doing that, we need to make sure we kind of do a filter out by that birth country equals Canada. And then when we're going by the year here, instead of using the count function that I used earlier, I group by the year and then summarize this year. And then it's going to actually give me a very similar thing that it did before. Just going to be a slight bit different. Yeah, it's just going to be called year count now. And then I can actually join these tables by year. And then we're going to get birth year here, and it's going to have all my year counts and all my weights. So that's going to be pretty good. And then what I also wanted to show you guys is the graph as well. So we're going to highlight these because this is still going to be useful for us. And then instead of from NHL from 1955, given they were born, average weight per birth year in the NHL from 1995 to 2005 for Canadian born players. This is really what we want to look at now. This graph is going to be a little bit different than the one before, just because we had those little edits, and it really doesn't look much different at all. So if you can kind of look here, let me pull this down for us here so I can actually look at this. We can look here and we can actually see that, yes, it is looking very consistent and almost the exact same as the graph before. And all the explanation of the graph before does apply, except when we look at this year count, the amount of players per year, the amount of players that were born in 1996 is now not 600, it's 50, because I actually had done my filtering correctly. So I just want to go back through and make sure that was clear. Let's kind of think about what topic number 3 is. So let's go ahead and go over here. How team weight and height of teams per season. Why do I keep putting how at the beginning of this? I don't know. But basically, it's looking at the average weight and height of teams per season. So per season. So let's go ahead and look at this. And let's see what we can kind of decipher here. So what we really need to figure out is how can I get weight, height, and season all kind of in the same area here. So what I'm going to do here is I'm going to join two tables together. So I'm going to get rid of this. I'm going to show you what I'm about to do here. I'm going to combine this players table with my original rosters. The reason I'm going to do this is because I want to add these players in here. So let's go ahead and just add these and make a bigger table just so we have a really nice size table so we can actually do some work with it. I'm going to call this big table. That's really what it is. We're going to do like a nice little inner join here between our players, rosters. Actually, going to do this by player ID. So, yep, we're going to do this by player ID. So here we go. Let's go ahead and see what this gives us here. This is going to give us a massive table. Massive table here. Oh, yeah, this is huge. Okay, so we have a massive table here. Doesn't really give us too much info just off the top because there's so much information here. I mean, we have, like I said, 5,000 or 54,892 entries. Okay, so let's move on to the next thing that we're going to do. What we're going to do next is we're going to kind of go into this thing. We're going to make a team data table. We're going to edit this big table. We're going to do some work here so that we can actually get into this table and get some stuff out of it. So we're going to group by, remember what I said we were kind of looking at here? We are looking at the height and weight per season per team. So why am I going to group by season and team code? Because first of all, we're looking per season. So we have to group by the season. And why am I going to look at team code? Well, because in the bigger table here, when we look at team code is going to be like the code for the team. So this is going to give us the code for the teams. So since I needed this, that's why I had to combine this players document. Because the players document is what had, players document actually didn't have my team codes. So maybe I actually didn't need to combine those two tables. Now that I'm looking at this, I might have just been able to do this by rosters. Let me look into this. Well, that's rosters T2. This is rosters. I think I actually might have been able to just do this by rosters now that I'm thinking about it. Because I have my height and weight here. So I might have actually just been able to do this by the rosters the data table. Now that I'm looking at this, I don't think I actually needed to combine these two tables. But let's just continue on here. And let's just continue. Summarize. We're going to use the summarize statement here. We are going to try to find the average height and weight. Now, what I'm actually going to do is I'm going to do team weight, and I'm just going to do the mean in pounds. And I'm just going to do the height in inches. Okay, so here we go. Now let's see what this team data table really gets us. If it gets us anything good. Well, it got us nothing. Well, because it's not called group. It's called group by. So that'll help us out most likely. A lot of times I do that. Okay, we now have this data table team, and we have their season, we have our team code, we have our team weight, and our team height. All right, so that's pretty cool per each season. It's pretty cool, a little bit of info there. And then what we really want to do now is we just want to kind of get in here, and we are going to join. So Right now I have my team code, but I actually have a data table called teams that we talked about really in the beginning. That's going to give me the actual team full name. So what I want to do is I'm going to create this final team data set. And what I'm going to do here is I'm going to interjoin this table I call this team data. And I'm also going to do teams, if I could type, by team code. Let's see what we get here when we do this. Okay, and look at this. So we now have our full name of our teams along with our team code. So that gives a little bit more information when we actually look at this table, what these team codes are actually meaning, right? So that's going to be what's kind of cool about this. So now we have a little bit more info on what this team is actually doing. So now, since we have our data table, we can now visualize this graph somehow. So let's go ahead and look and see. This is part of the code that I've already had written out for us. So as we look at this final team graph, this is a lot of code. This is a lot of different stuff here. So let's go ahead and look and just see what we do in the very beginning part. What we do in the very beginning, looks like we have this mutate statement here. So really this mutate statement, all this mutate statement is doing is it is saying we're going to make the season as numeric. So we're going to make the season a numeric variable instead of a character. Because right now the season is a character variable. So that's all we're doing in the beginning. So that's the only editing we've done so far. And then what we're going to do is we're going to filter. We're filtering out so that the season is greater than the 1999-2000 season. And also our team code is Chicago. So why am I focusing on this? Well, I'm from Chicago, so I wanted to focus a little bit on the Blackhawks here. So basically what we're going to do here, let's see what this kind of looks like. Just the beginning of this. Let's go ahead and run this final team graph. Looks like it's right here. So now we have the height and weight, the average height and weight for the Chicago Blackhawks since 2000, since the 2000-2001 season, up to this current season. So that's pretty cool. But now what we're actually going to do is we're going to kind of do a little bit of graphing here. So when we're kind of getting into the graphing here, what we really need to look for is we really need to look at what we're actually kind of looking at here. So we're graphing our season by our team height. So I chose a variable team height. And I can actually do GM point here because I made my season numeric. So that's going to help us out a little bit. Now, when I'm looking at why do I have all these GMV lines in there? This is an extra thing I added in just because I thought it'd be a little kind of fun because in that time period, the Blackhawks did win 3 championships. So what I did was I added a line in there just to signify when they won the championships. We can maybe compare the height when they won the championship to the height when they didn't and see how if that played a role. So that's kind of why I added those in. That's not in a data set or anything like that. That's not included. I just added that in and looked it up to verify that. So let's go ahead and look and see here. And I do have my titles in here. How height relates to titles, season, and height in inches. And I'm actually going to change this title. I don't like this title. How height relates to titles. How height relates to Stanley Cup success, if I could spell that right. Well, I hope that's spelled correctly. I feel like it's not. I think we're good. Okay, let's go ahead and run this up. Get this on full screen visual. Okay, so first off, I really just want us to focus on what we have on our Y and our X axis here. So on our Y axis, looks like we got our season, or on our X axis, looks like we have our season. So that's what we have on our Y axis. And then when we look at height in inches, we can see that we do have that on our Y axis, but I want us to look at what this is going to. Looks like we're starting at about 72.75 inches on the bottom, and we only get up to about 73.75 inches. This is a very small little snippet of the height. So what this is telling me is these are actually not as spread out as they seem. And we do see the 3 signified lines that are going to tell us when we won the championship, which is pretty cool. So we can see the height when we did that, the average height. So what we can see here when you just glance at this graph, you may say, wow, it's very, very variable. It has no relationship. But when we think about it differently, we can say, well, since the y-axis is so condensed or in such a small area, it's going to look very spread out. But if we had this in a different area, let's say from 0 to 70, 0 to 80, it would all look very, very similar. So we know that these heights are very consistent across years. So that's what we can really say. They're only varying by about an inch. So that's really not too much. So that's what we can really say from this data just based on this. So that's pretty cool. Okay. Now, topic 4. Let's look and see what topic 4 is going to be looking at here. Percent of hockey players born in each month. Wow. That's kind of a cool thing to look at. So let's kind of look and dive into that and see what we can actually discover. Okay, like I kind of stated again, I had already kind of wrote out some of this code so that we can kind of get through this a little bit faster, and we'll still be typing out the graph. Per usual, we've been switching off typing out the data and then typing out the graph. Okay, so right now we're starting out with this rosters document again. Rosters and players are the most powerful things here that we have because they do have the most information. So let's go ahead and dive into the rosters. We're going to make this year as numeric. Why are we going to do that? Well, I don't quite know if there's a true reason for that, but the reason we're filtering out greater than 1990 is because I want us to take another look at this births document. Since we're looking at trying to see how many births per month, we need to use this births table. And since I only have years since 1991, so I have to do greater than 1990. So that's why we're going to filter out this. So if you were not born since 1990, you're not included. You're not included in this. So that's what we're going to be doing here. So here we go. We're going to do this. We're going to filter out. And then what is this doing? What is this little guy doing? This mutate statement. Well, this mutate statement is really getting at the idea that when we look at our rosters table as it is currently, the original rosters document, we're going to go back and we see that this month is 0309. It's also a character. And when we're working with these months, we don't necessarily need it to be a character. We can have it be numeric. So what we're going to do is we're going to get over here. We're going to make this month as numeric. And then we're going to string remove. We're going to use str remove. We're going to remove that 0 out. I don't want that 0 in there. So we're going to just remove that out using that stringer package. We're going to just disregard that 0. So let's go ahead and run this up to this month. And let's see what this is going to get us to. All right. Rosters M. Here we go. Let's get in here. Okay, now look at this. My month has no zeros on it. Perfect. That's exactly what I want. And my year? Since 1991. That's perfect. That's exactly what I wanted. Okay. Now, I'm also going to filter by birth country equals Canada. That is just another thing that I've been doing just so that we have all the information from Canada, because that birthings data table or the births data table is only related to Canada. So that's why I'm doing that. Roster M. So what is this? What is this next statement here? What is this next statement doing? Well, this next statement really took me a minute to kind of come up with. The reason it did was because I originally was going to use unique player ID, as you see here. Filter player ID equals unique player ID right below this. The reason I had to look up how to kind of use this not duplicated statement, and what this is really going to do is just going to say if we have a player ID that's duplicated, we're going to throw it away. We're going to throw away the duplicate, not the original. We're going to throw away the duplicate. So why I had to do this is because if I just use the unique player ID, it's only going to give me the players that played for 1 year. Why is that going to do that? Because we got to think about this. This is the rosters document. This is the rosters for every team for every season. So if I use unique player ID, if a player played for 2 years, he's going to have 2 player IDs in there because he's played for 2 years. So I'm only going to get the players that played for a single year in the NHL, but I don't want those. I want every player that played for the NHL. So I really could just use my players document here, which probably would have been much easier, but I'm using the rosters, so we already kind of went in this way. So let's go ahead and get in here, and let's kind of use this non-duplicated statement here, and let's see where this gets us. From players that played in Canada with a birth year greater than 1990. 595 looks like what this is going to get us to. A players both born in Canada, a year since 1991, but also all just the players from that. Okay. So now let's go ahead and look into this roster month. And we're going to go back into this roster M data set. Is what we're going to go back into. Why do I have this filter player ID equals unique player ID? This is just a checkup. This is a check on myself to make sure that it got everything and all the player IDs are unique here. This is why I put this in, and looks like it is going to be the same because this is roster M and this is roster month right here. They both have 595 observations. So then why am I grouping by month? Well, I'm grouping by month because in my birthing data here, let me pull this up and keep this up. It's by month. So we have the year, yes, but we also have the month. So I can actually group by month. So I'm going to group by month and summarize my month count as N. Let's go ahead and do this. Let's go ahead and do this. Boom. Okay. Let's see here. Where's my rosters month at? This is the count of births in each month of that subset that we had created before of the data set. So this is going to be a count of, so we have 100 players that were born in January in Canada since 1990. That's pretty much what this is telling us. That's pretty much what this kind of information is giving us. So now, what is this births E? What is this data table telling us? Well, we're going to have our births and we're going to group by months, and then we're going to summarize the month total, or the births per month is what we're going to do. This month total is going to give us the births per month. So what we're going to do is we're going to have our births table. We're going to group by the month, and then we're going to basically just get the sum of the births, and that's going to give us the month total. And let's see what this is going to give us. This is going to give us a cool little thing here. Oh, so basically what this is doing is we have our births table. It's taking this month in 1991, in 1992, and we're adding all those up. So that's all we're doing. So when I go to birth E here, so I have 94,000 births in January since 1991. It is what this is telling me. And that may seem unrealistic because I have 32,000 right here. But if I go to 1992, 31,000, is doing this correct? Well, yes, that is correct because I read that number off wrong. That's 941,370. So yeah, that makes a little bit more sense if I could read numbers off correctly. So yes, we do that. And then actually what we're going to do now is I'm going to combine these two tables based on the month. That's why I really made that month numeric because the month is numeric here. So I'm going to kind of combine this up here, interjoin these tables. And that's going to give us this hockey birthing information. And that's going to allow us to get rid of all these different tables. So we've now created a master table that gives us what we need. Look at this. Look at that. That's beautiful. Okay. Now we're going to get in here hockey birth month. We're going to group by the month again, but then we're going to summarize, right? We're going to make a percentage. So we're going to do the percent of hockey. We're going to do the month count divided by the month total. Why month count divided by month total? Because month count is the amount of hockey players born in that month since 1991. And this is the total births born in that month since 1991. And we're going to multiply by 100 to make it a percent. And this is going to make us a hockey birth month. Wow. Look at this. So if we were born in January, it looks like you have a 0.01% chance of being a hockey player. But if you were born in December, you have a 0.00347% chance of being a hockey player. That's kind of a cool little piece of info. So now we're actually going to graph this up. We're going to try to visualize this in a way that makes sense to us. So let's get in here. We're going to call this probably hockey birth graph. We're going to get in there. And let's see what we want to graph this as. So really what we're going to do now is we're going to go to hockey. Oh, I can spell. Birth month. And then we're going to pipe off this. And then from here, we're actually going to do a little mutate statement. And why? Because really what I want to do is I want to make these month numbers. I would love to make them words. I'd love to make them words. So what I'm going to do is I'm going to mutate my month statement to month.a bb month. Now, what this should do is this should give me the those numbers we have And the hockey birth month right now, they should turn these into like January, February, March, April, May, June, July, August, all to December. So that's what it should do. Now, what I'm gonna do now is I'm actually just gonna start graphing this. And I'm gonna get in here, yes. And what I'm gonna do is month, and then by percent hockey. And I'm actually gonna use a column graph here or a bar graph. And yet again, I'm going to add all my titles in because I think titles are key. What should this be? Okay. Percent. This is going to be a long title of births in Canada. Since 1991, that so percent of births in Canada since 1991 in each month that are hockey players is what this really data table is getting at here. And then, of course, we're going to want to make our X labels and our Y labels. X lab. It'd be nice if I did this. This label is going to be month. Y label is going to be percent chance of hockey player. That's what this is really going to tell us here. So then let's go ahead and run this up. Actually, what I'm going to do before I run this up, I'm just going to type this out. So we actually get something that prints out something so we can look at it. Okay, so we have now done all this. Let's see what we get. Oh, look at this. Okay. So, what we have here is it looks like for each month, we are now going to have the percent chance that you're a hockey player. And it looks like January is our biggest month. It looks like we did this alphabetically here instead of by actual, like the order of the months. I'm not sure quite why that did that. Let me go into this. It must have been like when this function ran through, it just changed this because these are the right numbers for each because we know January was going to be the highest. And we know that February, let's go ahead and back and look here. We know February was going to be 0.008. Let's go ahead and look in 0.008. That's about what that is. So we know that these are accurate numbers and it assigned them accurately. It just assigned these months in alphabetical order, which can be a little bit inconvenient to look at. But when we actually look at these, since we have the abbreviated word, we can actually now kind of look at that a little bit better. So we know that in January, we have the highest percent chance. If your kid is born in January in Canada since 1991, that's going to be the highest percent chance that they're going to be a hockey player just based on that. And we can actually make this a little full screen just to make it a little bit easier to see. So yeah, and that's going to be the analyzation of this data. Today, we answered a bunch of different questions and we kind of went over a bunch of different things and we were able to visualize a variety of different things, which is pretty cool. What we were able to find was, in the last one, we were able to find the percent chance that you're a hockey player born in each month, given that you were born since 1991 and that you were obviously born in Canada. So that's pretty cool. In our topic 3, we were able to find the average height and weight for each team for each season. So that was pretty cool when we went over those. Graph number 2 or topic 2, we were able to find the average height and weight for each birth year. So that's kind of a little cool info as well. And then for topic number 1, we kind of really looked at the percent chance that if you're a hockey player born in Canada, that you're going to be born in a given amount of cities. And we know that we saw that Toronto, if you're born in Canada and you're a hockey player, there's the highest percent chance that you're going to be born in Toronto. So that's kind of cool. So that's kind of what we've gone over today. And I'm just glad you guys joined me along. All right.